multiplying the same number line with minus 3. We obtain the numbers as 15, 12, 9, 6, 3, 0, minus 3, minus 6, minus 9, minus 12, minus 15. Again, we observe that the same difference is existing between each successive terms, that is 3. From the above two observations, we can conclude that the product of one positive integer and one negative integer is always a negative integer. Rules of multiplication of integers. The product of two positive integers always is positive. The product of two negative integers always is positive. The product of one positive integer and one negative integer always is negative integer and vice versa. Let us do a simple activity to choose the correct option for multiplication of integers. Choose the product of a positive integer and a negative integer always is a negative integer. The product of two negative integers always is a positive integer. Let us further discuss about multiplication of more than two negative numbers. Let us assume the numbers minus 3, minus 4, and minus 5 and multiply them as shown on the screen. As we know that product of two negative integers is a positive integer. So, first multiply minus 3 and minus 4. Thus, we obtain it as 12. Then, multiply the resultant number 12 with minus 5 and its product is obtained as minus 60. In this way, we multiply many negative number of integers. Let's see some examples of multiplication of more than two negative numbers. By these examples, we can observe that if the number of negative integers being multiplied is even, then the obtained product is a positive integer. If the number of negative integers being multiplied is odd, then the obtained product is a negative integer. Let us now perform an activity to know the multiplication of more than two negative numbers. Drag the suitable answer from group B for group A and drop it in boxes. The product of even number of integers is always a positive integer. The product of odd number of integers is always a negative integer. Here we are going to discuss the multiplication of two or more numbers in an easier way. In our previous classes, we learned how to multiply the two given numbers, say 20 and 32. In general, we do multiplication as shown on screen. The easiest way to do multiplication for the above given numbers is as follows. First, write the number 20 as usual, and for easy solving, write the number 32 as 30 plus 2. Now multiply 20 with 30 plus 2. We get as shown on screen. Similarly, to multiply the numbers 20 and minus 98, write the negative 98 as minus 100 plus 2. And
let us solve a few exercise problems. Click the tab to view.
Now, let us study about the division of integers. Division is nothing but the inverse operation of multiplication. We know that the product of 5 and 4 is 20. Therefore, the inverse of it is 20 by 4 is equal to 5, or 20 by 5 is equal to 4. So, for every multiplication statement of natural numbers, there will be two respective division statements. Let us see some examples on division of integers. From the above table, we conclude that we get quotient as a positive integer when we divide two negative integers. Let us have a look on rules of division of integers. If two positive integers are divided, we get positive integer as quotient. If two negative integers are divided, we get positive integer as quotient. If we divide one positive integer and one negative integer, we get negative integer as quotient and vice versa. Let us perform an activity on the division of integers. Select suitable answer from group B for group A and drop it in bracket provided against A. Here, we will learn about the properties of integers under addition. Properties of the integers under addition can be categorized as closure property, commutative property, associative property, additive identity property, additive inverse property. Click each tab to know more. Closure property defines for any two integers a and b. A plus b is also an integer. In the first statement, minus 9 plus of minus 8 is equal to minus 17. It concludes that the sum is an integer. In the second statement, 9 plus of minus 8 is equal to 1. It concludes that the sum is an integer. In the third statement, minus 12 plus of minus 12 is equal to minus 24. It concludes that the sum is an integer. Therefore, the above table follows closure property under addition. Commutative property defines for any two integers a and b. A plus b is equal to b plus a. The second statement, 2 plus 5 is equal to 7. And it concludes that a plus b is equal to b plus a. Same for the second and the third statements also as shown in the table. Associative property defines that for any three integers a, b, and c, a plus of b plus c is equal to a plus b plus c. In the first statement, 1 plus of 3 plus 2 is equal to 6, and in the second statement, 1 plus 3 plus 2 is equal to 6. And it concludes that a plus of b plus c is equal to a plus b plus c. Additive identity property defines for any integer a plus 0 is equal to 0 plus a is equal to a. In the first statement, minus 9. In the second statement, 0 plus of minus 9 is equal to minus 9, and it concludes that a plus 0 is equal to 0 plus a is equal to a. Additive inverse property defines that for any integer a, there exists an integer minus a such that a plus of minus a is equal to 0. Both the integers are called additive inverse of each other. In the first statement, 5 plus of minus 5 is equal to 0. And it concludes that a plus of minus a is equal to 0. Same for the second and the third statements as shown in the table. Therefore, the above table follows additive inverse property under addition.
Knowledge check.